This video tutorial is not intended to replace the information in the Hamilton T1 service manual. Calibration, testing and troubleshooting must be performed according to the instructions in the service manual. This video is intended for certified service engineers only. This module explains the major electronic components of Hamilton T1 ventilators with a serial number of 3000 or higher. The information also applies for Hamilton C1 ventilators with a serial number of 6000 or higher, for Hamilton MR1 ventilators with a serial number of 2000 or higher, and for the Hamilton T1 military version. In this module, we explain the major electronic components of the Hamilton T1. First, we take a look at the overview of all the electronic components, which we review in detail one by one. We start by discussing the control board and ESM, followed by the driver board, including the blower motor control, the display front components, the power supply, the cooling fan, and finally the communication board. The control board manages the analog output signals from all the sensors connected, then converts these signals to digital signals. It also generates signals to control the solenoid valves that are connected to this board. We will review the ESM in detail in the next slide. The RTC Gold Cap provides power for the device's internal real-time clock, also during the time when the device is not connected to a power source. The emergency buzzer and microphone for its supervision are part of the alarm logic that allows the user to monitor the device during operation and intervene if required. The voltage and sensor test points are used for troubleshooting and confirmation of proper voltage levels. Please refer to the service manual for the table of valid voltage ranges. Finally, the slot for the option board is discussed at the end of this module. The ESM board, or processor board, is the main computer in the Hamilton T1. It controls and monitors all the operations. Essentially, these are the following: MMI, or man-machine interface, display, touchscreen and keys, ventilation functions and pressure and flow controlling sensors, patient monitoring, and system supervision and alarming. We currently have two different versions of the board in the field. Note that only the EM10A ESM board, which was introduced after the EM01A, is capable of neonatal application. The connection of the processor system to the control board is realized by the FPGA, or Field Programmable Gate Array, which is part of the ESM board. The three capacitors located on the back of the board provide the power for the buzzer in case of a total power failure.
It is useful to know where the device stores the various types of data, because both the ESM board and the control board have some storage capabilities. The ESM board contains the software for application and service, configuration parameters for application, such as quick setup and device settings, options, also called licenses, that provide various application functionalities, log files, the real-time clock, and in software version higher than or equal to version 2.2.0, it also contains the ventilation hours. The control board contains the calibration values, part, serial and revision number for the components which have no individual EPROM installed, the operation hours, and the blower timer. Next, we look at the driver board. As its name indicates, the driver board is responsible for driving some components in terms of electrical signaling and power provision. It mainly drives the blower, fan, O2 valve, expiratory valve, speaker. Furthermore, it contains a power path selector to select the appropriate power source, battery management for charging the batteries, and energy recovery logic, mainly for the blower that we discuss next.
The blower module integrates a brushless DC electrical motor, which is controlled with pulse-wide modulation signaling. It has an integrated hall sensor that sends signals from the motor back to the controller. The switches V1 to V6 represent MOSFET transistors. They demonstrate the alternation of current supply to the three coil pairs in the motor. The drawing has been simplified just to explain its functionality. The switches open and close in a frequency so that only one coil pair gets current at a time. In this example, current flows through V1 to U and V on the motor side, and then through V4 to ground.
Next, V3 closes to bring the current to V and W on the motor side, and through V6 back to ground. Finally, V5 closes and brings the power to W and U on the motor side, and back through V2 to ground. The same loop continues on and on, depending on the required blower speed.
When the motor needs to brake during the expiration phase, switches V1, V3 and V5 close, and V2, V4 and V6 open. This allows the current to flow from the motor back to the driver board. Four big capacitors located on the driver board store this energy that is generated by the motor. During startup and in the inspiration phase, the motor requires a lot of power. The energy stored in the capacitors helps speed up the blower immediately. Now we have covered the driver board, we will have a look at the display front and its components. The front panel board hosts the keys for the user control. It connects to the alarm lamp LED, the LED backlight, the press and turn or P&T knob encoder, and the resistive touchscreen. The 8.4-inch TFT color LCD display connects via the adapter board to the control board. The 8.4-inch TFT color LCD is 640 by 480 pixels. A resistive touch surface is mounted in front of the LCD. It is a 5-wire touchscreen system that allows precise calculation where the surface is touched. It is rated for over 35 million activations and is highly resistant to scratches, abrasions and external contaminants. Next, we will see how a power management is implemented. The power supply's input power allows voltages of between 100 and 240 volts AC with 50 to 60 Hz. The only output voltage is 24 volts DC. In addition to the AC input, the Hamilton T1 also has a DC input. The input voltages allowed are between 12 and 28 volts DC. Various cable connectors are available for different uses in the field. The Hamilton T1 can be operated with one or a maximum of 2 lithium-ion batteries. Each battery has a capacity of 6.7 ampere-hours and provides 72 watt-hours. The backup operating battery time with 2 fully loaded batteries in a Hamilton T1 is typically 8 hours. The approximate recharging time for completely discharged batteries is 7 hours when 2 batteries are inserted at the same time. Let's have a look at the power management, its priorities and concept. If all power sources are available to a Hamilton T1, it selects the power source in the following order of priority. Firstly, AC power, then DC power, then battery 2, inserted in the unblocked slot, and lastly battery 1, inserted in the screw-locked slot. On this drawing, we can see again the 3 different possible power sources for a Hamilton T1. The AC power input, the DC power input, and the battery input. The power source selector is located on the driver board. This is also the place where the other voltages are regulated that are required for the different internal components. We will now move to the cooling fan. The cooling fan has 2 purposes. The first is to prevent the device from overheating, and the second is to prevent oxygen enrichment in case of leaks inside the device. Note that even when the unit is in standby mode, the fan runs in order to prevent the unit from overheating. The fan blows into the device. It is controlled by a temperature sensor, also called an NTC resistor, which is located on the driver board. The last component we want to look at is the communication board, sometimes also called the option board. This list provides an overview of the various communication boards available for the Hamilton T1 with red housing and the Hamilton T1 military with grey housing. Communication board 1 contains a CO2, nurse call and COM1 port. Communication board 2 contains a CO2, SPO2 and COM1 port. Communication board 3 contains a CO2 port only. The grey Hamilton T1 Military can only be equipped with the CO2 SPO2 and COM1 board. Cables to connect to the COM1 port come in 2 different lengths, while the nurse call cable is 2 meters long.